Quadratics. Lesson 1, it's a graphing review. You'll be able to identify the axis of symmetry, the vertex, the x and the y-intercepts of a quadratic function. You will be able to graph the quadratic function, whether it is given in standard, vertex, or factored form. You'll be able to solve a quadratic function by graphing, and you'll be able to convert back and forth from a standard, vertex, or factored form. Now, first, the vocabulary. So move this out of the way here. Standard form, y equals ax squared plus bx plus c. AOS, axis of symmetry. That's this guy right here. It's this line that's not part of the parabola, but it divides the parabola into two half planes. It cuts it in half, and the axis of symmetry goes through the vertex. To find the axis of symmetry from the standard form, you do negative b over 2a, where a is the coefficient of the quadratic term and b is the coefficient of the linear term. Axis of symmetry, negative b over 2a. Once you make this calculation, that is the x-coordinate of your vertex. Because remember, this vertical line, x equals, goes through the vertex. You then take this value and plug it in for x. I can do this. Into x here and into x here, and then evaluate this function to get the y value of your vertex. Remember, the vertex is a point, axis of symmetry is a line. Axis of symmetry has to be written x equals a constant. The vertex is your turning point. It is a minimum when the parabola or quadratic opens up. It is a maximum if it's been reflected over the x-axis and it opens down. The vertex form. This is also the form that we used in Unit 2 when we were doing transformations. This is a times the quantity x minus h squared plus k. The vertex form is the best one for graphing because h, x equals h, is my axis of symmetry, and then hk is the vertex. Remember that it has to be x minus, so h is whatever is being subtracted from x. The factored form, R1 and R2 are the solutions or the x-intercepts of the vertex. In this case, you have a, which is that vertical stretch or compress, times x minus R1 times x minus R2. The axis of symmetry is halfway between R1 and R2, so R1 plus R2 divided by 2. That value is your x. Plug that value in for x here and here, and solve. F of this, that's function notation. Okay. Now, let's take a look. Standard form. If I want to graph f of x equals 2x squared minus 4x minus 6, my axis of symmetry is going to be x equals negative b. Well, b is negative 4, so I'll put negative 4 here, over 2 times the a value. And the a value here is 2. So I'll put a 2 in. This gives me positive 4 over 4, which is just the value 1. So now, at x equals 1, I'm going to have a snaky line. It's really not a snaky line, but what can I say? That's my axis of symmetry. X equals 1. I'm now going to take that value and plug it in to the equation where I had x's. And then I'm going to evaluate. 1 squared is 1 times 2 is 2. 2 minus 4 is negative 2. Minus 6 is negative 8. So my vertex is at 1, negative 8. Remember, it's a point. So here's 1 and negative 8. I can put my vertex. The y-intercept, okay? Remember, the y-intercept occurs when x is 0. So if I put 0 in here and 0 in here, I wind up with negative 6. So this is going to be 0, negative 6. And I plot my point. Now the nice thing is because the axis of symmetry, I'm symmetrical on either side since I went 1 to the left. If I go 1 to the right, I know I'm going to have another point. Now, my x-intercepts occur when y is 0. So I can plug a 0 in, or that's kind of ugly because we haven't talked about solving by factoring or anything else yet, so I'm going to wait. The domain, I know the domain is all real numbers, or from negative infinity to positive infinity. The range, however, is going to be from negative 8, because that's going to be my minimum point, and then it's going to keep going forever in the positive direction to positive infinity. Now remember that my a is the same no matter what, whether I'm in vertex form or standard form, so I've got a stretch of 2. So where my pattern was right 1, up 1, it's now right 1, up 2. So remember I had 1, 1, 2, 4. Well, now I have 1 times 2, 4 times 2. So that means I'm going to go to the right 2 and then up 8. Ah, now I can quickly, from my graph, and I am graphing this not with a pen, but actually with a mouse. I know it looks like a child's drawing, but it's pretty impressive to me considering I'm doing it with a mouse. My x-intercepts are negative 1 and 3, or negative 1, 0, and 3, 0. Oops. Move my calculator there so I can draw 0. I have also connected the dots, so I've got the graph sketched of my parabola. Next up, if I have it in vertex form, the vertex form is what's really, really nice to graph from, because my axis of symmetry is just h. H, well, that's this guy right here, which is 3. So at 3, I can come here and I can do my, oops, bump, 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 bump. There's my line. My vertex is going to be at HK, or at 3, 2. So I got to 3, I go up to 2, and I can put my point. Now, the other things that we learned from before was this is a vertical compress of 1/2, and it's upside down. So where my pattern was 1, 1, 2, 4, I'm now multiplying my up, down by 1/2. So now I'm going to go right 1, down 1/2, right 2, down 2. Whatever I do on the right, I'm going to do on the left. And then I can, oops, draw my parabola. Okay. I can also see that my x-intercepts are at 1 and at 5. So I've got 1, 0, and 5, 0. I also know that it's going down, so my range is going to go from bottom to top. It's going to go from negative infinity up to 2. That's where it's going to stop. My domain, that's going to be from negative infinity to positive infinity, or all real numbers, because I can put any number in here. Now, the only thing I don't have is my x-intercept. And I could keep going, and I could go out 3, okay? And then that would be 9, and that would tell me that I would need times 1/2. So that would be 4.5. So I could go out here, and I could go 1, 2, 3, 4.5. Okay, and that would tell me that I'm at 0, negative 2.5, The other way that I could do it, if graphing weren't easy, is I could plug a 0 in here. 0 minus 3 would give me negative 9, oops, would give me, sorry, positive 9, because I'm squaring it, times negative 1/2, which would give me negative 4.5, and then up 2. Okay? So, oops, plus 2 plus my 2 there would give me my negative 2.5. And that's what I've got. So either way, working it out algebraically or graphing it. Finally, we've got graphing from the factored form. Okay? Graphing from the factored form, we've got x plus 1, x minus 3. This tells me that at negative 1, oops, and positive 3, I have x-intercepts. That's where the factored form is helpful. So I've got negative 1, 0, and 3, 0. Some other things that you also know, the domain is going to be from negative infinity to positive infinity. Now, the vertex, okay, I've got to figure out what's halfway between negative 1 and 3. So I've got negative 1 plus 3 divided by 2. Well, this becomes 2 divided by 2 is 1. So x equals 1 is my axis of symmetry, and my vertex is going to be on this axis of symmetry. So I'll take this value and I'll plug it in. So y is going to be equal to 2 times negative 2, which is negative 4. So I come down here and I put my point. I can also look, a here is 1, so I can go right 1, up 1, right 2, up 4, and boom, I'm on my point. So I've just confirmed I'm graphing it correctly. I can draw a picture of I can connect the points so that I've got a sketch of my graph. Hopefully you guys can do a better job with paper and pencil than I can with a mouse on a computer. I can also now see from the graph that my y-intercept is at negative 3. Oops, sorry, is at 0. I got ahead of myself. Is at 0, negative 3. Now, if I wanted to do this algebraically, I would plug a 0 in here and a 0 in here, and that's 1 times negative 3 is negative 3. So either way, I get the y-intercept. The range, looking at my graph, the bottom is at negative 4. So I'm here at negative 4, and I keep going up to positive infinity. Okay? All right. Now, given a calculator, a TI-84, or Desmos, the way you can graph, you press y equals on your calculator, and it will bring up this. And by the way, before you do anything on your calculator, you should always do second plus, okay? So second plus is down over here, 712, and that will clear everything out. So if you've got any statistics graphs or anything like that set up, it'll clear those out so that this will graph nicely. But once you've got it set up, you simply press y equals, enter the equation as you have it, x squared minus 4x minus 6. Make sure that you do minus and not negatives there, otherwise it will give you a problem. Then you can press the zoom key and select number 6, which is z standard. That will give you a graph from negative 10 to positive 10 on the x-axis and negative 10 to positive 10 on the y-axis. You simply press zoom and select 6, I'll bring the cursor down here, and you'll get this graph. On Desmos, you simply type in y equals x squared minus 4x minus 6, and it, boom, just gives it to you. And then you can readjust your scale here, your axis, as you need to. Now, the x-intercepts are also called the solutions, roots, and zeros of a function. If the vertex is on the x-axis, it is the root. There's only one root that occurs twice. We say that it has a multiplicity of 2. We're not going to get a lot into multiplicities right now. I'm just mentioning this word, so down the pipe, when you hear it again, it'll start to make a little more sense. Essentially, even multiplicities are turning points. That means if it happens 2 or 4 or 6 times, it's going to touch at that spot and turn around. It's going to be a turning point. Odd multiplicities, on the other hand, cross over. More on this in another unit. Now, and again, this is just sort of a foreshadowing, so you've heard it once before. Not all roots are real. Non-real roots occur for a quadratic equation when the parabola does not touch or cross the x-axis, like right here. Notice it's not touching or crossing. When asked for the solutions of a quadratic that does not touch or cross the x-axis, when you're doing it by graphing, you can state no real solutions. Once we learn how to algebraically find an imaginary solution, you will be required to state the imaginary solution. But for now, no real solution will work. Now, solve the following quadratics by graphing. Take a moment. This first one is in standard form. The second one is in vertex form. And this third one is in factored form. So go back and use what we did before. Pause the video and try that. Okay, and then I will come back and put it all together for you. Okay. And you're back. So now we have this first one. Let's do this. Okay. Here's the graph, and here's the graph. Okay. I'm going to go through each one of these. Let's see if I do the right color pen. So x equals negative 8 all over 2 times 1. So this is 8 divided by 2 is 4. So here's our axis of symmetry. And then our y value will be equal to 4 squared minus 8 times 4 plus 15. You can put that in your calculator. You get 16 minus 32 is negative 16 plus 15 is negative 1. There, and then there's, it opens up, it's not reflected, and it's a standard one, so it's right 1, up 1, boom, right 2, up 4. You can put your points, and then you draw your smooth curve. You can then note that your solutions, which are the x-intercepts, roots or zeros, those are 3, 0, and 5, 0. For the blue one, okay, x equals 2, because that's my h value right here. So that's my axis of symmetry, and notice it does cut right through where the vertex is. To find the vertex, that's my k value. So this is easy. It's 2, 9. I come down here at 2, 9. I put a point. Then using what we learned in our transformations unit, a is equal to 1, and my pattern's 1, 1, 2, 4, 3, 9. Right 1, up 1. Right 2, up 4. Right 3, up 9. And I hit the x-axis. Now what I did on the right, I can go over on the left and do the same thing. So that way I can get a nice, clean, smooth curve. And then I can write down my solutions are -1, 0, and 5, 0. I can also here identify my x-intercept very easily. It's at 0, -5. Domains are all negative infinity to positive infinity. Ranges, the red one is -1 to positive infinity. The blue, -9 to positive infinity. Finally, moving over here to the green one. This one, the negative tells me it's reflected over the x-axis or opening down. I'm going to have a point at -3 on the x-axis and a point at 1. So right here, I already have my solutions. My solutions are -3, 0, and 1, 0. But if I still need to graph it, then I need to do x equals -3 plus 1 divided by 2, and that's going to give me -1. So here's my axis of symmetry is x equals -1. Then I'm going to put a -1 in here and a -1 in here, and I'm going to compute it. This becomes 2 times -2 is -4, and then I've got the negative, which gives me +4. There's my vertex at -1, 4. Then again, it goes down, no stretch or compress. So right 1, down 1, right 2, down 4. Left 1, down 1, left 2, down 4. I draw my smooth curve, and I've already identified my solutions. Nice. Now, you've got a foldable that shows 2 solutions, 1 solution, no solutions. Take a moment, pause the video, and work through those. I will then go back over each one of those answers, just as I did those other 3 problems. Remember, these are like guided examples. Okay, so hopefully you've completed your examples. Let's first look at where you have 2 solutions. X squared plus 6x plus 8 equals 0. Solve it by graphing. And this one's -x squared plus 8x minus 12. Here's the first one. Notice I found the axis of symmetry and the vertex. Okay, and then I use the fact that A is 1, and it opens up to go right 1, up 1, right 2, up 4 to draw the graph. My solutions are at -4 and -2. You do need to know what those are in terms of a point, but for the small space you have to write and the foldable, just writing -4 and -2 are good. Example 2. This one, you wound up with an axis of symmetry at 4, 4. Our axis of symmetry is x equals 4, vertex at 4, 4. It opens down, right 1, down 1, right 2, down 4. And your solutions are 2 and 6. If you need to take a little longer to write in any of this information or to show the work, pause the video and then restart it when you're ready. Moving on, 1 solution. Okay. Example 3 and example 4. If you didn't already do these, pause the video now and then restart it when you're ready to check your answers. Ready? Here's the first one, and here's the second one. Again, and these are all in standard form. So x equals -b over 2a. You get your vertex, plug it in. Notice that the y value in both of these is 0. That means that if I were to factor this, this would be x minus 3 times x minus 3. 3 is a solution that happens twice, a multiplicity of 2. Over here, again, I would have such that this would happen twice. Finally, no real solutions. Solving both of these by graphing. If you haven't done these, pause the video and do so, and then restart. Ready? Here's this one, and here's the next one. Notice A is positive, so it opens up. In order for there to be no real solutions, the vertex must be above the x-axis, so it opens up and away from the x-axis. On the other hand, example 6 opens down. A is negative. The vertex is below the x-axis, so it opens down and away again from the x-axis. Converting from standard form to factored form and to vertex form. Okay, this is just converting back and forth. For this one, converting to factored form from standard, factor the beast. If it's not factorable, then the quadratic cannot be written in factored form. It's that simple. Okay, recall prime expressions, and you would just say prime. Now, this one, if we're going to factor it, first thing I'm going to do is take out a 2. So I'm going to factor it to 2, and then I have x squared minus 2x minus 3. I now need factors of -3 that will add to -2. Well, that's going to be x minus 3 and x plus 1. Now it's in factored form. Now, if I want it in vertex form, that means I need my h and k. So that just means I need my vertex. Okay, remember a is the same. So to find the vertex, I'm going to do x equals -b divided by 2 times a. That's going to give me 4 over 4, or 1. And then y is going to be equal to 2 times 1 squared minus 4 times 1 minus 6. This is going to be 2 minus 4 is -2 minus 6 is -8. So my vertex form is just going to be f of x is equal to 2. Remember that a is the same. And then I'm going to have x minus my h value, which is 1. This quantity squared, and then it's plus -8, or just -8. And that's it. Well, what happens if you have it in vertex form and you want it standard form? Well, first, you're going to multiply it out. So, to give myself enough room, I'm going to keep the -1/2 out here for right now. Okay? And then I'm going to multiply this out. So you're going to get x squared minus 6x plus 9. And then I still have my plus 2. I'm going to distribute the a, which is -1/2. So I'm going to get minus 1/2 x squared, and negative times a negative is positive. Half of 6 is 3. X negative times a positive is minus 4.5, or 4.5. And I still have my plus 2 out here. And I have to combine my like terms. So I have f of x is equal to -1/2 x squared plus 3x minus 2.5, or 2.5. Factored form, factor the standard form. Okay, this is going to be a little bit ugly because we have fractions and stuff, and I will tell you that I'm not ever going to ask you to factor this for me. Okay, that just really wouldn't, it would be crazy, because when we factor things, we factor it over integers, not over fractions. So this is the standard form. If I ask you to go to factored form, it's going to be something that factors nicely. Okay, so next up, converting from factored form. If I want to go to standard form, all I do is I multiply it out. So this just becomes f of x is equal to, I'm going to FOIL it, so I've got x squared minus 3x plus x minus 3, and combining my like terms is going to give me x squared minus 2x minus 3. Now, if I want to go to vertex form, well, if I'm going to go from my factored form, first thing I need to know is what is the x value and what is my axis of symmetry, or the x value of the vertex. So I've got -1 is equal to R1, and 3 is equal to R2. So I've got -1 plus 3 is 2, or that's 1. So now I have the 1 here. Now I'm going to put the 1 in here, and I've got 2 times -2 is -4. So -4 is the vertex. Then I look back up here, and the value of A is 1. So I don't really need to put the 1 there. So this would really best be written as simply x minus 1 quantity squared minus 4. And we'll do f of x. Okay? And that's going back and forth. Think about you have to think about what do you know, what do you need, and go from there. So in summary, to find the x-intercepts, solutions, roots, or zeros, basically synonymous of a quadratic function graphically, you're going to, the quadratic equation must be set equal to 0. Standard form, vertex form, factored form. Graph the quadratic by hand or using a graphing utility, meaning the TI-84, Desmos, the Casio, or some other graphing program. Then identify the location or locations, if any, where the curve touches or crosses the x-axis. Where it touches or crosses the x-axis are the roots, the zeros, the solutions. When we get into the applications, we will talk about why the solutions are so important. That's it for now.